This is Check Your Understanding for Unit 4, Sections 1 through 3. So let's start with the first problem on your Check Your Understanding. My problem might be a little different than your problem, but the concept should be the same. All right, so this question says, a book cover has a length to width ratio of 5:3. So I'm going to actually draw our book here. Here's our book. The length is 5 and the width is 3. That's the 5:3 ratio. We want to select all of the following that could also be actual measures of the book's dimensions in these next set of problems. So what I'm going to do is I'm going to find the constant of proportionality. Remember that if this was the x column and this was the y column here, to find my constant of proportionality, I just divide the y by the x. So 3/5 is my constant of proportionality. So I'm going to go through and multiply the first column by my constant of proportionality to see if it equals my second. And if it does, then it's proportional, and if it does not, we are not proportional. If I multiply 40 by 3/5, then that book's dimensions would also be 24, so that is a proportional relationship. If I multiply 9 by 3/5, am I going to get 15? Well, 9 times 3 is 27, divided by 5 is not 15. So the first one was, this one was not proportional. If I look at the next one, I have 17.5. If I multiply that by 3/5, we get 10.5. So this one is proportional. I know the next one is not because I already found what 40 is when we multiply by 3/5. That is equal to 24, not 10.5. So this one is a big no, that is not proportional. And the next one is 15 times 3/5. Does that equal 9? Yep, because 15 divided by 5 is 3, times 3 is 9. So this one is proportional. So we find our constant of proportionality. If it helps to kind of put those into a chart like that, you can. And then you just check to see if multiplying the constant of proportionality gives you the second number. All right, this next problem says a photograph measures 2 inches by 3 inches. So let's draw that out. We have 2 inches by 3 inches. Definitely a picture that is not to scale. Then we have a second photograph that measures 7 inches to 10.5 inches. I'm going to see if the scale factor, because they're actually asking for the scale factor here, is the same for each one. So if I take this first one and I do 7 divided by 2, we get 3.5. If I do the second one, 10.5 divided by 3, we also get 3.5. So because my scale factor is the same for each one, we would say these are scaled copies of each other, or scaled versions. So we will say they are scaled copies, and we're going to put our scale factor in as 3.5. Because it is 3.5 for both dimensions going from the small version to the big version. Okay, this next one is a recipe, and I believe the best way to do this is a visual. So we're going to take here a table that's going to help us see. So we have the salad dressing calls for 1.5 cups of olive oil and 3/4 cup of vinegar. Okay, so in my original recipe, I have 1.5 cups of olive oil for 3/4 cup of vinegar. Now, a good place to start is finding our constant of proportionality. So if I have 1 cup of olive oil, how much vinegar do we have? We can find that by taking our 3/4 and dividing it by 1.5. So I'm going to get my calculator out and do that. And I get 1/2. So 1/2 is my constant of proportionality there. Okay, I'm going to use this table now and my constant of proportionality to answer the next questions. It says, how many cups of olive oil do I need to mix with 12 cups of vinegar? Well, we're starting from the right column and we want to find the left. So to go from 12 to this one, we are going to divide. So we're going to go 12 divided by 1/2, which should give us 24. So this first answer here would be, we need 24 cups of olive oil to get 12 cups of vinegar. Hopefully that makes sense to you because our olive oil is a little bit more than what we have for the vinegar, so it should be greater than the vinegar. The next one says, how many cups of vinegar, there we go, how many cups of vinegar do we need to mix with 15/4 cups of olive oil? So in that instance, we are trying to find our vinegar and we know we have 15/4 cups of olive oil. Well, our constant of proportionality is 1/2, so if we're going to go from this one to here, we just multiply by our constant of proportionality, and we get 15/8 cup of vinegar. Or if you don't like that weird number, you can say it is 1 7/8 cup. All right, the next question here says, I'm just going to keep filling my chart in. How many cups of olive oil do you need to make 100 cups of salad dressing? Now this is a really tricky question. I'm going to let my olive oil be my x, and I know that my vinegar then would be 1/2 x. If I took these two together, my x plus my 1/2 x, because we're adding them to a dressing, we need that to be 100 cups of total salad dressing. So we've got to try and figure this equation out. If I have 1x and I add it to 1/2 x, that's 1 1/2 x equals 100. So we need to figure out 1.5 times what number is equal to 100. There's a pretty simple way to do this, and you'll learn more about it when you're solving equations. But essentially what we can do is we can just divide 100 by 1.5. And when you go and do that, you get 66.67 cups. Or if they want you to keep it as a fraction, it would be 200/3, which is a lot. Kind of a weird number. But there you go. That is a weird problem. You probably won't see anything too much like that until for a couple more units, but it's nice to see it a little bit ahead of time. Okay, this next question says, Violet bought 1.5 pounds of gumdrops for $7.50. Okay, we have Piper bought 3.5 pounds of jelly beans for $5.25. And Adam bought 3 1/8 pounds of peppermint for $3. So there's my people, Violet, Piper, Adam. Which candy is least expensive per pound? Now that per pound is a huge clue for us. it tells us that we are finding the unit rate. So we're going to find the unit rate for each of these. So to find the unit rate, we are just going to take our unit, which is money, and put it into per pound. So we're going to divide our money by the number of pounds. So Violet's is $7.50 divided by 1.5. Piper is 3.5 pounds of jelly beans for $5.25. So I just mixed that up. So that's $5.25. We're going to divide that by 3.5. And Adam bought 3/8 pounds for $3. So we're going to take our $3 and we're going to divide by 3/8. So I'm going to go and calculate each of those out. Violet ended up being 5. Piper's candy cost about $1.50 per pound. And Adam's cost $8 per pound. So the candy that is the least expensive per pound was Piper's. Hers was only $1.50 per pound. Now they don't ask you that, but it's good to know. The candy that's the most expensive was Adam's Peppermints. His was about $8 per pound. So in these problems, we are just trying to find our unit rate. And these next problems are going to involve us using an equation in the problem. So we have Gavin is at the farmer's market. He buys tomatoes. So here's our tomatoes and the cost of the tomatoes. So he buys tomatoes. So for 1 pound of tomatoes, it costs $1.92. So if we bought T pounds of tomatoes, we would just multiply our pounds of tomatoes by T to find out the cost of the tomatoes. So when we're writing an equation, the cost, C, is equal to 1.92 times the number of pounds of tomatoes. It's just our constant of proportionality, but instead of having numbers, we multiply it by a variable, in this case, T. So if Gavin's tomatoes purchased cost $120.96. How many pounds of tomatoes did Gavin buy? So we put the cost in the cost column, and to go backwards, we are going to divide our 120.96 by the cost, and we get 63 pounds. So he bought 63 pounds of tomatoes. I can't even imagine that. So there we go. It's pretty simple writing the equation if you understand what the constant of proportionality is doing to the first column. This next problem says a train is traveling from Washington, D.C. to New York City. It travels d miles in t minutes. The equation is relating d to t by d equals 1.1 t. So t is going to be our independent variable because it's inside the equation, and d is our dependent variable because it's what we are trying to find. So it's saying how fast is the train moving per minute? This is just our constant of proportionality. So the constant of proportionality from an equation is just the constant that is in front of our variable. So it is 1.1 miles per minute. The next question says, how far does the train travel in 40 minutes? So we got 40 minutes here. We're going to just put, that means our time, our time t is equal to 40. So that means that our distance d is equal to 1.1 times 40. So that means that we are going to have traveled, if we multiply those two, 44 miles. Now the tricky one here is how long does it take the train to travel 82.5 miles? Well, what we have here is our distance. That means our d is equal to 82.5. So if we use our equation and we put that in for d, we've got 82.5 is equal to 1.1 times our time. Not our distance, our times our time. And that is actually what we're trying to find. So if we just take our 82.5 and we divide by 1.1, we get our time equals 75. That means we travel 75 minutes and 82.5 miles. This is just a question where we have to be able to use an equation. And we'll do a lot more of that in the future, but it's really nice to see this. Okay, the next question, this last question actually for this practice says, Addison mixes a particular shade of pink paint called Watermelon Wow by combining half a pint of white paint and 3 quarts of red paint. How many quarts of red paint should Addison mix with 3 pints of white paint to make Watermelon Wow? Okay, I am going to set up a table here. We have the variables in our table are white paint and red paint. In the original problem, it says we have half a pint of white paint, so I'm going to put 1/2 a pint of white with 3 quarts of red. And then the question is saying, so let's see, I'm going to highlight those. We have half a pint of white and 3 quarts of red. Okay, the next thing says, how many quarts of red should we mix with 3 pints of white? So I'm going to put those pieces in the table. We have 3 cups of white and we're trying to figure out how much red we need. So what we're going to do is we're going to find the constant of proportionality by taking my second column and dividing my first column. So 3 divided by 1/2 is 6. So that means for every 1/2 of a pint, there are 3 quarts of red, so half times 6 is 3. So then, in order to figure out how much red paint we need, we're just going to take our 3 times our 6, and it's going to be 18. 18 quarts of paint. Now that is it for that problem, but one thing that we did a lot with this is, let's say whatever our x was, we knew our y in the situation, so that was our x. We can multiply by whatever our x is by 6, and that can give us our y. So we can set up a fun little equation for that, and whatever we wanted to put in for x, we could find our y. It's kind of a cool thing that you can do with these.